This module is gonna be about electronic measurements, and binary numbers are gonna be used quite a lot, especially with ADC and DAC converters. In other words, analog to digital converters or digital to analog converters. So before we dive into that, you must have a very clear idea of how binary numbers work, and that's what we're gonna talk about in this video. To understand them better, we should first review some things about decimal numbers, or numbers in base 10. They are called numbers in base 10 since they can have 10 possible values when writing their digits. 0, 1, 2, all the way up to 9, which is exactly 10 values. So if we take, for example, the number, let's say 5323, you've probably heard that we can say that this number has 5 thousands, 3 hundreds, 2 tens, and 3 ones. So we can write this number as 5 times 1000 plus 3 times 100 plus 2 times 10 plus 3 times 1, which is equal to the original number with which we started. Since we are first multiplying with a number that has 3 zeros in it, so 10 to the power of 3, then with another one that has 2 zeros in it, so that's 10 to the power of 2, all the way up to 1, which has 0 zeros in it, we can always compactly write decimal numbers in the following form. Now that we wrote it in this way, we can multiply it with the numbers from above to see that it actually makes sense. 5 times 10 to the power of 3 plus 3 times 10 to the power of 2, 10 to the power of 1, 10 to the power of 0, and this is equal to the following. And you can actually see that this right here is the same thing as the thing from above, which means that we got exactly the same number from above. Now, if we want to see how to represent natural or real numbers in base 2 instead of base 10, we have to do a very similar reasoning actually, even though just seeing ones and zeros seems non-intuitive at first. I will give you an example with a smaller number to understand things better at first. So what we are trying to do is write a number in a form that has just ones and zeros, for example 1, 1, 0, 1, and see what decimal number it represents. In this case, it represents the number 13, but we'll get to that in a second. In the same way that in base 10 we had to multiply the digits by 10 to the power of something, now in base 2 we have to multiply the digits by 2 to the power of something, since it's in base 2. So we can write from above 2 to the power of 0 in the same way as we wrote it before. 1 times 2 to the power of 3 plus 1 times 2 to the power of 2 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 0. We can also not write this term right here since it's 0 multiplied by anything is equal to 0, but I just wrote it to make sure that we have the whole process. Is equal to, this term right here is 8 plus 4 plus 0 plus 1 times 1 is equal to 1, which is equal to 13, expected. Now, no matter how long the binary number is, using this exact method you will always know what decimal number we are talking about. With binary numbers we can also do operations like sum, subtraction, division, multiplication. Most commonly used in uni is sum, but that's a topic for another video. I hope you enjoyed this one.